When dealing with a 4.16 kilovolts, 1000 horsepower motor exhibiting a phase-to-ground fault, a systematic approach is essential to determine the appropriate course of action. The initial step involves a thorough visual inspection, followed by a series of electrical tests to assess the condition of the motor's insulation. Start by ensuring the motor is de-energized and tied out for safety before commencing any inspection or testing. Firstly, check for any loose connections. Examine all cable lugs, terminal points, and ground connections for tightness. Loose connections can sometimes mimic a ground fault or exacerbate an existing one. Secondly, carefully inspect the insulation of the motor windings. Look for any visible signs of damage such as cracks, blisters, tracking, or discoloration. These could indicate insulation breakdown. Next, conduct a megohm insulation test, commonly known as a megger test. This test applies a direct current voltage, typically 500 volts or 1000 volts for a 4.16 kilovolts motor, between the motor windings and ground. The resulting resistance measurement indicates the quality of the insulation. A low megohm reading suggests a potential fault. For a 4.16 kilovolts motor, the minimum acceptable insulation resistance is generally 1 megohm per kilovolt plus 1 megohm. Therefore, a reading below 5.16 megohms would warrant further investigation. Consider performing a partial discharge test. Partial discharge testing can detect high-frequency electrical impulses caused by insulation defects. This test is more sensitive than a megger test and can identify developing insulation problems before they lead to a complete failure. The test involves using specialized equipment to measure radio frequency emissions or ultrasonic signals generated by partial discharges within the motor windings. Elevated partial discharge activity indicates insulation degradation and the need for repair or rewinding. Another valuable test is surge testing. Surge testing involves applying a high voltage surge to the motor windings to stress the insulation and identify any weak points. This test simulates the voltage stresses that the motor may experience during switching operations or lightning strikes. The surge voltage level is typically several times the motor's rated voltage. During the test, the voltage and current waveforms are monitored to detect any signs of insulation breakdown, such as flashover or corona. A successful surge test indicates that the motor's insulation can withstand transient voltage stresses. The decision-making process after testing involves careful consideration of the results obtained. If the tests reveal significant insulation damage, such as low megohm readings, high partial discharge activity, or insulation breakdown during surge testing, the motor should be sent for rewinding. Rewinding involves removing the old windings and replacing them with new ones, restoring the motor's insulation system to its original condition. This is a significant undertaking that requires specialized equipment and expertise. If the fault is minor, such as a loose connection or a small insulation defect, it may be possible to repair the motor without rewinding. Repairs may involve cleaning and re-insulating the affected area, tightening connections, or replacing damaged components. However, the long-term reliability of a repaired motor may be lower than that of a rewound motor. If the tests indicate no major insulation defects and the motor has not experienced any performance issues, it might be acceptable to continue operation. However, close monitoring of the motor's performance is essential. Regularly check for signs of overheating, vibration, or unusual noise. Periodic insulation resistance tests should also be performed to track any deterioration in the insulation system. Consider the cost of rewinding versus repair. Rewinding is generally more expensive than repair, but it provides a more comprehensive solution and restores the motor to like-new condition. Repair may be a more cost-effective option for minor faults, but it may not address underlying insulation problems. The severity of the fault and the potential risk of motor failure should also be considered. A severe fault with a high risk of failure may justify the cost of rewinding, while a minor fault with a low risk of failure may be addressed with repair. Also consider the availability and lead time for rewinding services. Rewinding can take several weeks or even months, depending on the size and complexity of the motor. This downtime can significantly impact operations. Evaluate the impact of motor downtime on operations. If the motor is critical to production, it may be necessary to have a spare motor on hand to minimize downtime during rewinding. When evaluating insulation resistance, consider temperature correction. Insulation resistance is temperature dependent, with resistance decreasing as temperature increases. When comparing insulation resistance readings taken at different temperatures, it is necessary to correct for temperature variations to obtain an accurate assessment of insulation condition. Use industry standard temperature correction factors to adjust the readings to a common reference temperature, typically 20 degrees Celsius. Regarding polarization index, also known as PAI, this is another diagnostic test that can provide valuable information about the condition of motor insulation. The polarization index is the ratio of the insulation resistance measured after 10 minutes to the insulation resistance measured after 1 minute. A high polarization index indicates that the insulation is in good condition, while a low polarization index suggests that the insulation is contaminated or degraded. A polarization index of 2.0 or greater is generally considered acceptable for motors. For the dielectric absorption ratio, or DAR, it is the ratio of the insulation resistance measured after 60 seconds to the insulation resistance measured after 30 seconds. The dielectric absorption ratio provides information about the moisture content and contamination of the insulation. A high dielectric absorption ratio indicates that the insulation is dry and clean, while a low dielectric absorption ratio suggests that the insulation is moist or contaminated. Furthermore, consider offline versus online testing methods. The tests described so far are offline tests, which means that the motor must be de-energized and disconnected from the power supply to perform the tests. Online testing methods, such as motor current signature analysis, can be used to monitor the condition of the motor while it is running. These tests can detect mechanical and electrical faults that may not be apparent during offline testing. When performing a step voltage test, apply voltage in steps and observe the current. This test can reveal hidden weaknesses in the insulation that may not be detected by a standard insulation resistance test. The voltage is applied in steps, and the current is measured at each step. A sudden increase in current indicates a potential breakdown in the insulation. Also consider a high potential test or HEPUT test. This test applies a high voltage to the motor windings to verify the integrity of the insulation. The test voltage is typically several times the motor's rated voltage. If the insulation can withstand the high voltage without breaking down, it is considered to be in good condition. However, a HEPUT test can be destructive, so it should be performed with caution. Remember to analyze oil samples if the motor is oil-filled. If the motor is oil-filled, oil samples should be taken and analyzed to assess the condition of the oil and to detect any contaminants. The oil should be tested for dielectric strength, acidity, and viscosity. The presence of contaminants such as water or particulate matter can indicate insulation problems. When testing, adhere to safety precautions. Always follow proper safety precautions when working with high-voltage equipment. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Ensure that the motor is properly grounded before performing any tests. Never work alone, and always have a qualified electrician present. For the National Electrical Code, or NEC, compliance, ensure that all repairs and rewinding are performed in accordance with the National Electrical Code, or NEC. The NEC provides guidelines for the installation, maintenance, and repair of electrical equipment to ensure safety and reliability. Also consider motor efficiency. When rewinding a motor, consider upgrading to a more energy-efficient design. Energy-efficient motors can save significant amounts of energy over their lifespan, reducing operating costs and environmental impact. Regarding vibration analysis, this can be used to detect mechanical faults such as bearing wear or rotor imbalance. Vibration analysis involves measuring the motor's vibration levels and frequencies. Elevated vibration levels or unusual vibration patterns can indicate a mechanical problem. For infrared thermography, it can be used to detect hot spots in the motor windings or connections. Infrared thermography involves using an infrared camera to measure the temperature of the motor surfaces. Hotspots can indicate insulation breakdown, loose connections, or other problems. Also consider the motor service factor. The service factor is a multiplier that indicates the motor's ability to handle overload conditions. A motor with a higher service factor can withstand greater overloads without overheating or failing. When testing, evaluate the motor's nameplate data. The motor's nameplate provides important information about its electrical and mechanical characteristics. This information is essential for selecting the correct testing procedures and interpreting the results. Also consider the motor's operating history. The motor's operating history can provide valuable insights into its condition. Factors such as operating hours, load cycles, and environmental conditions can affect the motor's lifespan. If the phase to ground fault is significant or there are concerns about insulation damage, it's highly recommended to send the motor for rewinding to ensure its safety and reliability. Rewinding the motor will restore its insulation system to its original condition and provide years of reliable service.